Okay, so looking at some application problems dealing with linear equations. The first one I see here is we have a total of 67,000, which is to be invested, some in bonds and some as certificates of deposits, which are called CDs. If the amount of the bonds is, if the amount invested in the bonds is to exceed that in CDs by 5,000, okay, how much will be invested in each type? So my suggestion when you're dealing with word problems, read through it and then start reading through it again and start bringing out the information and put it on the page. So I noticed that here we have a total of 67,000 to be invested. $67,000 is invested. And I noticed that there's two different types of investments. We got our bonds and we got our CDs. And the amount, if the amount invested in bonds is to exceed CDs by 5,000. So I'm going to need to start defining what I want my variable to be. So if I let X equal the amount invested in the CDs, it says if the amount invested in bonds is to exceed. So I know that the bonds is going to exceed my CDs by the amount of 5,000. So I can write out bond, my bond, the amount I'm going to invest in bonds is X plus the additional $5,000. So we have $67,000 that we're investing. And we know that we're investing some in our bonds, but our bonds, the amount that we are investing in our bonds is X plus 5,000. And then the amount invested in our CDs. So we want the amount invested in our bonds plus the amount invested in our CD is X. So part of the problem is determining what your variable is going to represent, then setting up the equation to answer the problem. And so now we can solve that equation we set up. So we have 67,000 is equal to combining like terms on the one side of the equation. 1x plus 1x is 2x plus 5,000. Isolate your variable. So we would subtract 5,000 on both sides. 67,000 minus 5,000 is 62,000 is equal to 2x. And then dividing both sides by 2 to get x by itself, we get 31,000. So x is 31,000, and that was the amount that we were investing in our CDs. So $31,000 is invested in the CDs, and x plus 5,000 is in the bonds. So 31,000 in here plus our 5,000. So we're investing $36,000 in our bonds. And if we sum those amounts that we found for each one up, it is equal to the amount that we have invested in both accounts. Okay, so the next problem I have in front of me states that Trisha is paid time and a half for hours worked in excess of 40 hours. They had a gross weekly wages of $783 for 52 hours worked. What is a regular hourly rate? So the question is asking me what the hourly rate is. So that's usually what I would define my variable to be. So let X equal the regular hourly rate. And so we know that time and a half is what she's getting. So 1.5 times her normal rate is equal to her over 40 hours. So we know that she's worked a total of 52 hours. So 40 hours is regular pay. And so anything over 40 hours, which is 12 hours, she worked for overtime. And we know that the total amount of the paycheck was 783. Let's say that that was, and that's gross, so without taxes taken out. So let's set up our equation. So we have 40 hours times or that's times the rate of pay, which is X, plus we have time and a half, which is 1.5x, times the number of hours worked, which is 12, and it didn't matter which order I had written that multiplication, they're the same. And this is equal to the gross pay of $783. So go through, let's simplify. This is 40x plus, well, 1.5 times 12. That is 18x is equal to 783. So 40 plus 18 is 40, no, it's not, is 58x is equal to 783. So X is 783 divided by 58. Let me grab a calculator. So 783 divided by 58 gives us X is equal to $13.50. So we just answered what her regular pay was. $13.50. So the next example in front of us says going into the final exam, which will count as 2 tests. Amelia has test scores of 77, 84, 74, 63, and 94. What does Amelia need to get on the final in order to have an average score of 80? So it looks like Amelia's trying to shoot for a B here. And so we need to think about averages and how to find averages. And I know to find an average, I'm summing all the scores and dividing by the number of scores. The one thing that we have to worry about is that the final is worth 2 test scores. So we need to remember that when we're setting up the equation. It's asking us again, what does she need on the final? So that should clue you in. That's what we're going to choose our variable to represent. So X is equal to the amount or the grade needed on the final. So again, finding averages, you're summing everything up. So we have 5 scores here. She had 77 plus 84 plus 74 plus 63 plus 94 plus what she needs to get on the final. But again, this final is worth 2 test scores. So I'm going to write it as 2 times X, making it weighted as 2, is equal to, or in the actually average, we need to divide by the number of scores that we added up, treating the final as 2 different tests. So we have 5 plus the the final. So that's divided by 7 is equal to, they want to get an 80 in the class. So they need to have this equal to 80. So we can clear our fraction. We can multiply both sides by our denominator here of 7. That's going to cancel out this denominator. So let's go through and let's sum our scores. So we have 77 plus 84 plus 74 plus 63 plus 94, which gives me 392. Plus that 2x.
I have a question.
Mhm.
Sorry, I looked away for a second and I was like, what? Where did you get the 7 from?
Because in order to find the average, we want to find averages. You sum how many entries that you're finding the average of and dividing by that number. And because the final exam is worth 2 test grades, we're going to treat it as 2 tests when we sum this up. And so we have, the score of 77, 84, 74, 63, and 94. So there's 5 tests before the final, plus the final, which is worth 2 tests. So that's,
Oh, okay. I understand now. Thank you.
yep. And so now we summed up those numbers plus 2x. This is equal to 7 times 80, which is 560. So linear equation, variable, term with a variable on one side, we would subtract 392 on both sides. So I get 2x equals 560. Go back up here, use my calculator. 560 minus 392, which give us 168. So dividing by 2, I see that that is an 84. So in order for Amelia to maintain a B or get a B in the class, they would need to get an 84 on the final. So the next example, the college bookstore marks up the price that it pays the publisher for a book by 40%. If the selling price of the book is $95, how much did the bookstore pay for the book? Okay, so basically, again, we're looking at the question. It's asking me how much does a bookstore pay? So that's what I'm going to choose my variable to represent. So X equals the bookstore pays, or the amount the bookstore pays. Well, they're taking this and they're marking it up 40%. So a couple ways that you can think about this. You can think about it as a bookstore pays the X amount. Then they're going to charge that amount plus 40% of the amount that they paid. So 40%, when you're taking a percent of something, you put it in decimal form. So I'm going to take 0.4. I can put the 0 there if I want, but I really don't need it, times the amount the bookstore paid. And this is equal to the amount the student will pay, and the student or selling price is $95, which again, I don't need that decimal 0.00. I could put it in there if I like. Or you can think of it as the student is paying 140% of the price the bookstore paid. And you'll notice that if I added that together, this X plus 0.4, well, that's 1 plus a 0.4 is 1.4. So this is 1.4x is equal to 95. And let's divide 95 by 1.4. And that should give me the amount the bookstore pays. So 95 divided by 4 gives us back $67. Since this is money, I would just round to the nearest cent. And it's 0.85. The next number is 7. So I'd round it up to 86 cents. So the bookstore, they pay $67.86 for that book. They're selling for $95. So the next example in front of us, we have a manager of a theater. They want to know if the majority of their patrons are either adults or children. One day they sell 5,200 tickets and they get a receipt back of $19,528. We know that the admission is $5.50 for an adult and it's $2.50 for a child. And how many adult patrons were there? So this is what it's asking. So let's choose X to equal the number of adult tickets sold. So if X is the number of adult tickets sold, and we know that the total number of tickets sold was 5,200, well, I would subtract off X from that to get the number of tickets that were sold for kids. So 5,200 minus X, this would equal the amount of kid tickets sold. Okay, so if we take how many adult tickets were sold times the price of the adult tickets, that would just give us how much money they made off of the adults. So an adult admission is $5.50. So I have $5.50 times the number of tickets sold. And now I'm going to add the amount of money we made off the children. So we know that the children's price for admission is $2.50 times the number of tickets sold, which was that 5,200 minus X. So summing up the amount we made on children and adults, we know that we made $19,528. So we've set up the problem and now we need to go through and solve it. So let's simplify down the left-hand side. We can do that by distributing the $2.50 or 2.5 to each piece. So I have 5,200 times $2.50. That gives me 13,000. So plus 13,000 minus 2.50 times X. This is equal to 19,528. I notice I have like terms on my left-hand side of the equations. Let's combine those. I have $5.50 minus X times minus $2.50 X. Well, 550 minus 250, that's going to give me 3X plus 13,000 equals 19,528. So let's get X, the term with X by itself. Let's subtract 13,000 on both sides of that equation. So we get 3X equals, well, 19,528 divided by, minus 13,000 is 6,528. So let's divide both sides by 3. We probably can do this without a calculator. Well, I know 3 goes into 6 twice. 3 goes into 5 only once, but I have a remainder of 2. So I'd have 22. 3 goes into 22 7 times with a remainder of 1. So 3 goes into that 18 6 times. So it looks like the number of adult patrons or a number of adult tickets sold was 2,176 tickets. And then if we wanted to find the number of children tickets sold, we would just subtract that number from 5,200. So next question, the perimeter of a rectangular window is 28 feet. The width of the window is 6 feet more than the length. What is the dimensions of the window? Okay, so I know for perimeter, to find the perimeter of something, I'm adding all the sides. And so we have the length and we have the width. And the width of the window is 6 feet more than the length. So I'm going to choose, I like L for length, L to equal the length of the window. And the width is equal to 6 feet more than. So that's telling me I'm adding 6 to the length. So it would be L plus 6. So I'm going to add all sides. So I have 2 lengths of the rectangle plus 2 widths. So I have length plus L plus 6 plus L plus 6. This is equal to the perimeter of 28. So now let's just go through, add like terms. I have 1, 2, 3, 4 L's. So that's 4L plus 6, which is plus 12, equals our 28. Let's isolate the term that has L in it. So subtracting 12 on both sides, 28 minus 12, that gives me 16. And divide both sides by 4. 16 divided by 4 is 4. So we know the dimensions, and this is in terms of feet. So the length is 4 feet, and the width is 4 plus 6, so 10 feet. So the dimensions are 4 by 10 feet for that window with those conditions. Okay, so the next problem, last type of word problem that you'll see on the homework, we have Herschel. They use an app on their smartphone to keep track of their daily calories for meals. One day his calories for breakfast was 122 more than the calories for lunch, and the calories for dinner were 200 less than twice the calories for lunch. If his caloric intake from meals for the day was 2,138, determine the calories for each meal. So since they gave me breakfast in terms of lunch and they given me dinner in terms of lunch for calories, I know that I'm going to want my variable to represent the number of calories for lunch. So maybe let's do L, which is equal to the number of calories eaten for lunch. Okay, so now let's go back and express what breakfast is. So B for breakfast. Going in here, one day the calories from breakfast were 122 more than. So I know that I'm going to take the number of calories from lunch plus 122 more calories. Now I want to also set up the number of calories that were eaten for dinner. So for dinner, there were 200 less than twice the calories for lunch. So 2 times the number of calories for lunch, and there was 200 less than that. So minus are 200. So to set up the equation, we're gonna sum the calories for lunch, breakfast, and dinner, and we know that that sum was this 2,138. And I'm gonna express this each meal in terms of my number of calories for lunch. So I have my lunch calories, L, plus my breakfast calories, which is L plus 122, plus my dinner calories, which was 2L minus 200. The sum of all of our meals was 2,138 calories. So I notice I can simplify on the one side by combining like terms, L plus 2L. That would be 4L. And then I have negative 200 plus 122. So opposite signs, I subtract. 200 minus 22 is 78. But the larger number had the negative in front, so this is minus 78 equals 2,138. Isolate the term of the variable L, so that means I would have to add 78 to both sides. So we get that 4L is equal to, carry, 2,216. Get L by itself, we're going to divide by 4. Well, 4 doesn't go into 2, but it goes into 22 5 times with a remainder of 2. 4 goes into 21 5 times with a remainder of 1. And then, not 5, 4 goes into 21. And then 4 goes into 16 4 times. So it looks like Herschel had 554 calories for lunch. They had 122 more than that for breakfast. So let's add 122 to that. So that would be 676. And then for dinner, it's twice, so 2 times the amount, 554 minus 200. So that's 11,008 minus 200, which would give me 908 calories. So we just went through a lot of different application problems that you will see in solving linear equation section in your college algebra textbook. So hopefully all those questions that we went through were very helpful for you. And if you have any questions, please reach out and get a hold of me.